Hey there! Hi, I'm Aisha. So this video is intended for our course assignment Engineering Statistics. This is not an entertainment video, so please be supportive, okay? In this assignment, we have 4 questions. Questions A, B, C, and D, and will be explained by my friends Rodi, Shabil, Ming, and Tanjai. So please be supportive, okay? Listen and enjoy.
My name is Shamirodi bin Shamsuddin and I'll be presenting the part A of the project assignment, which is the data analysis. By using the data provided, we are able to visualize all of the data characteristics presented by the data by analyzing it through the tabular and numerical form. First thing first, we'll be doing the tabular analysis, in which all of the components, which are weight, relative density, tensile strength, and shift, will be divided into few classes, and all of the frequency for each classes will be counted from the data. Next, we'll be doing the numerical analysis, in which all of the mean, standard deviation, and mode for the components, which are weight, the relative density, tensile strength, and also the shift, will be found through the data. And thus, by sorting the data into respective shifts, which are morning, evening, and night, we will be able to see the characteristic of the data way more detailed, in which the sample size for the morning is 68, for the evening is 62, and the night is 70. Thus, all of the mean, standard deviation, and mode for each of the weight, relative density, tensile strength for each shift can be counted from the data. Next, to ensure the data is easier to be analyzed, it is best to visualize them into diagrams and graphs. Thus, some graphical analysis and histogram analysis have been done. For example, for the first graph, which is the tensile strength, appears highly determined by the weight, which is, we can see that the weight does not affect the tensile strength based on the data trend portrayed by the graph above. Thus, we can actually conclude that the problem that happened does not caused by the weight of the large acrylic tablet, and the problems might be caused by some other factors. For the next graph, which is the relative density and the tensile strength, appears highly correlated. The tablets got stronger as the relative density of the measured tablets increased, as seen by the value of the tensile strength of the tablets. Moving on to the third graph, which is the relative density by the weight, a change in weight has no effect on the relative density in any way. This is because the pill will never weigh more than 400 milligrams or be lighter than 300 milligrams. For the last graph, which is the relative density and the tensile strength against the weight, the tablets, according to the graph, never weighed more than 400 milligrams and never weighed less than 300 milligrams. The tensile strength never exceeds 10 megapascal and never falls below 5 megapascals. And their relative density never reaches 100% and never falls below 80%. For the histogram analysis, for the frequency of tensile strength histogram, the mode of the tensile strength in the histogram for tensile strength is 40, with the tensile strength ranging from 7.0 to 7.1 MPa. For the next histogram, which is the frequency of relative density, the histogram reveals that the mode has two ranges, which is the first one is 86.1% to 87.1%, and the second one is 88.1% to 89.1%, with both frequency of 33. While for the last histogram, which is the frequency of weight, the majority of the pills in the data collection, which is the 663 in total, were determined to be between 338.35 and 348.35 milligram in weight. Thus, it summarizes all of the data analysis for the project assignment.
Hi, I'm Shabil Ahmad bin Sazali. I will be explaining the information needed on question B. Based on the question, the Food and Drug Administration FDA authority stated that they require the weight of standard tablets produced by the manufacturer are normally distributed with 350 mg and with a standard deviation of 14 mg. With the data given, we can test whether the tablet produced do follow this distribution or not by using the chi-square test. We will be testing the goodness of fit at 5% level of significance, where alpha is equal to 0.05. Follows the state of hypothesis for this test, in which HO stated that distribution weight of standard tablet follow the normal distribution, while H1 stated that the distribution weight of standard tablets do not follow the normal distribution. Then we organize and group the data as in the table. The range of data is converted into probability by using this formula. Z equal to X minus 350 divided by 14. To find the expected data EI, we need to use the formula N multiplied by PI, where N is the total value, which is 200, and pi is the expected probability. To verify whether this table is in the correct method, we use the summation frequency from the grouping data to verify it. We can see that the summation frequency of OI and EI are equal, which is 200, and the summation of probability pi are equal to 1, showing that this table correctly verified and ready to be used. Since EI less than 5, we need to merge the data. After merging the data, a new observed value OI prime and expected value EI prime data are obtained. We can obtain the chi-square test value from the summation of OI prime minus EI prime squared divided by EI prime. We use the significant level alpha equal to 0.05 and the degree of freedom V equal to K minus P minus 1, where K is the number of categories, which is equal to 6, and P is the number of unknown parameters, which are equal to 0 since there are no unknown parameters. Then the degree of freedom is equal to 5. From the statistic table, we can obtain that x squared alpha V is equal to 11.0705. The criteria set for the decision is that we reject HO if x squared test is bigger than x squared alpha V. The conclusion for this question is that x squared test, which is 6.6255, is less than x squared alpha V, which is 11.0705. This leads to that we are unable to reject HO, which means that the distribution weight of tablet lajak Curie K does follow normal distribution at alpha 0.05.
I'm Shiming Shi. So I'm going to present the C. So the question C is to present the required analysis and comment on whether there is any significant difference between table weights in milligram of the different shift. So first, we will arrange the data given according to shift. So by using the pivot table in the Excel tools, we can arrange our data from the data source, and from the pivot table views, we can choose the weight and shift the view to make our table in the black arrow. So in this case, we will use the one-way ANOVA test. So the one-way analysis of variance specifically allows us to compare several groups of observations, all of which are independent, but possibly which with a different means for each group. So the first step, from the data we arrange, so we go to the blue arrow for the second step, which is analyze data, and then we will get our result in the green circle, which is the third step. So next, from the result we got, we will analyze our result. So before this, we will make the analysis, which our H0 is mu1 equal to mu2 equal to mu3, and our H1 is mu1 is not equal to mu2, it's not equal to mu3. So in this case, we will take our alpha is 0.05 as the red circle. So we will reject the H0 if our p-value is smaller than alpha, and then we will reject H0 if our f value is greater than the f critical value. So from the result, so our p-value is 0.265926817 as the yellow circle is greater than our alpha value, which is 0.05 as we assume. So our f value is 1.333665972 as the orange circle is smaller than our f critical value, which is 3.04271,675 as the green circle. So we can make a conclusion, which is we fail to reject H0 and conclude that there is no significant difference between the table weights in milligram from the different shifts at 0.05 level of significance.
Hi, I am Tanjai and I will continue for question D. The question stated that tensile strength depends on the relative density regardless of production shift. With this statement, we can use the solving method by correlation analysis and test for linear regression. Independent variable x as relative density and dependent variable y as tensile strength. With the help of Microsoft Excel data analysis, we can have the result of output like this. As you can see, the table is actually showing us alpha head as intercept value and beta head as relative density. From these two linear values, we can actually obtain the linear equation in the form of y equals to beta x plus alpha. We also can use the data given in Appendix 1 to draw a graph with tensile strength as y-axis and relative density as x-axis. The result of the graph is drawn using Microsoft Excel as well. With the data plotted, we can use the software to plot a best fit line among the data. With the graph, we also can say that the prediction is valid for the relative density in the range of 82.1 to 92.9. To answer the question, we need to predict the tensile strength for relative density of 68%, 74.3% and 80.1%. For all three relative density of the question given, we can say that they are all out of range and the predicted tensile strength is invalid. For the correlation analysis, we can refer back to our result output data we have shown earlier. The correlation coefficient R is equals to 0.8446, which show that there is a strong positive linear relationship between the relative density and tensile strength. As for our square value, it is 0.7134, indicates that there is actually 71.3 of original uncertainties in the value of tensile strength can be explained by the linear regression model. Thus, the linear regression model is adequate. From ANOVA table, we can test the linearity with the value of f-test and t-test. The table also shows the value of significant f is less than the level of significance, which is equals to 0.05. Thus, we can reject the H0 hypothesis. In conclusion, at alpha equals to 0.05 level of significance, the data provide strong evidence on the existence of linearity between the tablet's relative density and tensile strength.
Thank you for watching. Bye bye.